Hi everyone. Hmm. Hi everyone. How are y'all doing? So today, I'm gonna try and convert this old lamp into from AC to DC, and well, we're gonna try and do it without rewiring any of this kind of stuff right here. So, AC wiring. It's just got this plug on the end. What we're gonna do, I 3D printed something, so it could just slide in here. It could just slide into this 3D print, have contacts come to it, and it's going to be plugged into USB. It's going to travel up the wire. We're going to replace this light bulb. It's not going to be an AC light bulb anymore. It's going to be DC. And, well, we're going to do this so that way I don't have to rewire this thing, because there's no way to physically rewire this device. So let's get started. So, yeah, our light bulb's right here. Let's take this lamp away first. We don't need the lamp. We don't need the shade for right now. So yeah, no, we're going to construct a bulb, a DC bulb, and we're also going to construct a what's it now? A DC bulb using parts. And we're also going to construct a plug element, so that way we can convert the regular standard, wall plug to a USB. It's going to sit right in there. Hopefully I did that. Oh yeah, no. It's going to sit right in there. Like that. So let's get started, cuz yeah. No, I want to get this finished. So that way I can have my grandpa's old lamp. He passed away, and well, right now, yeah. Well, right now, yeah, I'm still, I don't know, going through things or whatever. I don't know. And I just want to have this lamp of his. There's nothing special about it. It just used to be his, and I don't know. So anyways, which part should I start off with first? Let's construct the light bulb first. Alright, so let me get rid of the parts for the plug, and let's start on this. So, the first part is going to be... Ooh, I don't have a board for it. Nope. 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 Ah! I thought I was prepared. But, okay, so we're going to be using one of our light strip sensor PCBs that I've constructed, and we're gonna change it around a bit. So that way we can use it for other things. So right now, we're not going to care about that. We're going to just try and solder this together, because it's going to be... we're going to solder the board together first, and then we'll deal with the rest. Alright. Alright, now... got that. There. 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 And... oh, come on. There. Alright, so... that's there. And we're just going to solder this all together. We're going to be using a Wemos Mini D1 for this part of the project. Let's throw some music on real quick. Oh. There we go. All right. Oh. Darn it, I got it on an angle. Now it's going to have to stay there. There we go. All done there. Now flip it around. We're just going to do the back side of it. There we go. That's all done. Now if I want to, I can just take this off. And the next thing we're going to do is we're going to put a Dht sensor on it. Now, we're going to bend all the pins down. And we're going to cut off this one. There. Alright. Now because it's the DHT 11, that middle sensor, that one over here, that had no output really. And so now we're gonna just choose these three, and we're gonna go. Okay, I gotta find ground. And I think we're gonna do it this way. Wait, this way. Okay, so this was originally made for a PIR sensor. This breadboard was originally made for a PIR sensor, but because this is going to be inside of a structure, I thought maybe, well, with no visible way, it's going to have that lamp shield around it. Like that is going to have, it's going to have like a normal lamp shield around it, and it's going to be inside this thing with the lights wrapped around it. So you couldn't get an actual you can't get an actual line of sight between the board and a person. It's just going to sit inside this tube thing that I 3D printed. So I'd rather have it open with these air holes and just take the temperature around it instead of, you know, just being a waste of three pins. All right. Come on, let's do this. All right, I'm flattening out the pins so I can easily more solder this. Okay. We got 1, 2, 2. Come on. 3. And so hopefully these projects go better than the ones I've been doing, where it kind of just like meh and fizzles out. We're just gonna we're gonna snip these up, make it a little bit cleaner inside, so that way no things accidentally attached or pinch each other. All right, that's good. All right. Now we got to add the wires. So we're going to be using a light strip, a WS218B, 218B or something. And these run off of three wires. One is data, or red one's going to be power, green one's going to be data, and the last one's going to be ground. So with these with this type of LED, they just need a digital command to turn on and off. They don't need the standard RGB wiring up and the RGB and then a positive voltage or something. So it makes it a lot easier, more compact. I can throw it into this little setup that's like smaller than the size of my hand. This thing's pretty decent. And so then after we're done with this, we're gonna wrap the light strip up in in the LEDs. But for right now, we're gonna get this connector piece attached. Alright. Alright, we're just gonna twist these wires a bit. Now what's interesting is I gotta hook these up in the right way. So it's facing me. We're gonna attach the wires this way and this way. Okay. There's one. As soon as you get one in, they all follow. Well, hopefully. And you kind of want the cord to be right up against the solder joint. because you don't want these wires just flopping around. I'm also going to add some hot glue to them after the fact, but right now we're just trying to solder them in. There's one other one. And then the last one. There we go. There we go. Yep, we're good. Now I'm just going to trim these up so that way they don't accidentally ever meet. There we go. So we got our temperature sensor. We got our light strip, which we're going to plug into at some point. Not right now, because I've got to... I don't know. I'm going to attach the bottom. So what I did was I took an old light bulb and I just took the bottom off of it. And so that is going to connect straight to the electrical connections for the bottom of this. The only problem is that I've got to get this correct with the plug. I got to sync these up so that way the positive is always the positive and the negative is always the negative. So what I want to do is probably I want to take I need to solder a cord to the outer end for the power for this module. I also need to probably put a bigger cord from the center connection piece as well. And actually, we're going to use some recycling. Wait, can this go all the way up? Because I know after, I'm still going to have to try and solder these. Nope. It's like this is all really confusing because I gotta have it long enough so I can reach in there and solder, but short enough that it doesn't freak out. And some of these cords that I have are kind of thick. They're thick boys. You know what? I'll cut it, and then we'll just do what we do. We'll do what we do. Now, as a reminder, guys, I'm going to probably say this a few times. Don't ever plug... If you're going to replicate this project, don't plug what I do into the wall socket directly. You need USB adapter or something. Because this this and this will just blow up on you. These will blow up on you if you try and plug them into the wall directly. That's why I'm making special adapters and custom fittings for them, so that way they'll all stay together, hopefully, and we won't have an issue with it. That is my hope. That is my goal. Because I want to keep my lamp intact, because maybe someday I want to go back to AC. You know? The reason I'm doing this majorly is because this is going to be an automated light now. I'm going to attach this to my Home Assistant and have it just work. Alright, so now we're going to try and get this in the center here. You should really have something to hold this in place, though, because this is just not... Oh shit, it came out the bottom. No, mother... Well, the only way to get it back is to just reheat it and... No! Oh, man. So what was this originally supposed to do? Oh, it just screwed in there. It was never designed to be soldered on. Okay. We're just going to solder it straight on anyways. I don't care. Shit, it made a dent in my mat. Well, at least it's there now, and I can poke it through, hopefully. I can actually remove the other one. I gotta make that hole a bit bigger. If I had another one of these, I'd probably start over. But because I don't have light bulbs that are just lying around, I don't want to disassemble. Let's try and figure this out so I don't have to. There, maybe? Nope. I need to just probably aim for digging around over this side. I just really want to get that out. Maybe flatten this some too, so that way it doesn't... So it wants to go back in instead of just kind of like being forced in. This is all melted plastic, so... Yeah, you're gonna need... Come on, you. Just... Bend. You son of a... gun. Just go in. I gotta bend this into place. Come on, you. You know exactly what you're doing. Come on, don't piss me off. There we go. Alright, so that's back on. I'm probably gonna have to hot glue that, aren't I? Yep. Get the hot glue gun ready, because I'm gonna have to hot glue stuff anyways. That out. That out. Alright. Alright. Oh, turn it on. That might need a... There we go. Glue sticks ready on this end. Alright, so next thing is, now that I know that fits, I'm going to need to solder the other end onto the inside of this. I feel like I'm going to have to do it on the wood, because wood can withstand temperatures a bit better. I don't know. I'm sorry if I'm doing this off camera, guys. I'll show you the final result afterwards. No, why? Oh, because round things must be round. Alright, so we got that wire soldered on. Yep, no, you're good. We're good. Because the previous wire that was soldered on left. This was originally an LED light bulb for growing gardens. And so I just took it apart because I don't need a 3-watt LED bulb. I got the iDo, whatever it is. And so now we got our positive and negative leads. This is good. Hot glue is ready, I think. As it burns me. Yes, it is. Everything seems to want to burn me today. Oh, now you're not going in exactly the way. Okay, first off, this might need some more work. There we go. Oh, I can't really do it on this end, can I? Because I need this to be nice and smooth so it screws into a proper surface. So it's like tacked on there with whatever little hot glue I have. Now I'm just gonna dump the whole thing of this in there, and hopefully, oh god, no. And pull, and pull, and pull, and pull, so it doesn't fucking go. Huh. I mean, this stuff doesn't want to dry on the bottom. It's all still liquidy. If you can see that in there, it's still like liquidy. I'm also going to put a little hot glue on the negative wire just so we have it. Oh shit. Now I gotta place it in here. So one of these goes in through the side there, and then the... Oh shit. Now how... Okay, so one of them goes through this side wall. The negative is going to go through that one, and then the positive is going to go through there, and they're all going to meet in the center. Well... Motherfucker. So that didn't work out too well. So we're just going to toss them right in the center. And... Hey, there it goes. We're okay with this. Oh, son of a bitch. So that wasn't done cooling. Oh, now it is. It's cooled in the wrong spot, but I'm pretty sure it'll make an electrical connection. So, next thing is... trying to hot glue this base to the main light bulb section, I guess. Or, if I remember correctly, I'm actually supposed to solder it to here for right now. No, I'm supposed to glue it first, and then I can solder it. Damn glue stick. Glue stick, glue stick, glue stick. And... there we go. And then we're gonna just go around the outer edges as well. We're not going to get too high, because then that's not going to make the thing screw into the light bulb. Alright, there we go. Try and clean up all the spider webs it leaves behind really quick before it really solidifies on there. There we go. So we got, oh nope, we got a whole bunch of spider webs out here. Alright, now that we've gotten that done, we're going to twist these in, and we're going to put them in place. This should be the... Yep, that's the power. Wait, do these things have a 5-volt yeah, they should have a 5-volt or 3.3 volt regulator for the chip. I'm actually going to take this off. Because we don't need that until later. Alright, now... Oh, goodness gracious. There's one. Alright. There's two. And we're just going to solder right there. And so we got our thing there. So I want this to go kind of something down in there. So that way our sensor is kind of popping out one of the holes. Before we do that though, actually I don't know if you can see it right there, but some of our wires aren't exactly soldered. So we're just gonna solder them a bit more on that one. And on that one. There we go. And just clean up because there's like tiny threads coming off that. Tiny threads coming off this. And then we're gonna have everything covered in a supportive layer of hot glue. There we go, and just let it sit for a second. Okay, so while it's sitting, we're going to do something else. We're going to program this board. Oh, Okay. So we got our thing. We got a micro USB. I'm going to be programming it with Home Assistant. So if you guys don't already know, Home Assistant is kind of like, it's trying to be like Alexa, but open sourced. It doesn't have any vocalization, but it will have a whole bunch of other stuff. Like you can program screens with it. You can have different functions happen when it sees different sensors. It's a little bit more open because of that. But yeah, no. It does its thing, and you know what? I like it. So, okay, let's go to main screen. So this is Home Assistant. We're doing ESP Home. On the bottom right, if I can get out the way, you can see a new device. We're gonna click on that. We're gonna label this Grandpa's lamp. Next, we got to select the board. We're going to choose a specific board. We use the Wemos D1 Mini because that's kind of like the smallest one. That's why I chose those. And it's configured. We don't want to install it. Nope. We want to edit this first. We want to... Because none of you guys know where I live, so I don't care about passwords about my Wi-Fi. And when I do get a new place... I'm just gonna swap everything out because, yep, nope, not letting you guys hack me or whatever. Don't care. So I already have a code written out. I kind of just grabbed this all from this website, esphome.io. We can just go down to the fast LED lights. And we can just grab it from here. We just basically copy and paste what they have here, there, which is what I grabbed, which I can grab right here more easily. Copy. And this is just saying, basically, we want to run this code, the fast LED clockless. The chipset is WS2812B. That's the light strip I'm running. That's the kind of that's the kind of light strip I have. Those LEDs on the light strip. We're using pin 5 because we designed this in Easy EDA to output on pin 5. Now we have 60 LEDs on this strip, and the RGB order. So some strips have different ways of coding themselves. So sometimes the R will be what's supposedly supposed to be the red is changed with another color or something. So hey, Sports Better 2, how are you doing? Sorry, I got a little ranty there and just didn't check in with you guys. Normally there's no one here, so how are you doing? But yeah, right now I'm converting. I'm trying to convert my old lamp that my grandfather passed, and I got one of his lamps, and I want to convert it to okay, so I got Oh, nope. I got this lamp, and I'm going to convert it without replacing any of the wiring. We're going to have basically the light bulb right here, be smart, and change this plug, modify it, have an adapter so it can do 5 volts. So that's the project we're working on right now. All right, we are gonna do back to screen capture. So, all right. So where was I? The light. So we gotta figure out. Okay, so the whole way the YAML file works in ESP Home, or no, for Home Assistant is you got your device, your board, SSID, fallback hotspot, whatever. This is all automatically generated by just adding a new device. The Wi-Fi password you got to put in, and next is you got to put in your light, your source, whatever output you're doing. Followed by, well, in this case, we're using the fast LED clockless sketch that they have. We have to identify the chipset of the LEDs, which is WS2812B. The pin, which is where you're going to be using D5 on the Wemos chip. We're going to be using 60 LEDs? I think this strip is 60. If not, it'll light up only 60 strip of the strip. So that way we can like legitly see if it has 60 or not. I don't remember how many this has. The RGB order, which presumably is going to be the same for this one. And then what do I want to name it? Oh, we're gonna. Oh, yeah, we're actually gonna copy and paste this, to be honest, to our actual one, because that was a previous code I written up. Copy. We need to name everything. And we're just gonna copy and paste this. Paste. We have to, okay, so right here, we're on the light part. That's fine. Next is going to be the DHT sensor. DHT. Yeah, digital humidity and temperature sensor. We're using pin number 8. We got to name it. I'm going to put capitals here. It bothers me if there's no capitals. Because it's a proper noun, I guess. And so, again, we can grab this. If you ever need to research this at all, you can go to esphome.io. And they have like a ton of devices that they've integrated into their system. So like you don't need to code that much for this entire thing. So for the DHT sensor, here's the sensor. Here's the thing I really just copied. And it gives you a very detailed description about what each thing does and what things are required and which ones not. I should really put in model. Model DHT 11. Oh, there we go. And that should be it, right? Okay. Model manually and helps some connection issues. Alright. Alright, now that I got... Oh, nope. Wrong one again. Crap. Copy. I should really save that anyways, because all my stuff uses DHT 11, because it's the most simplest thing, the cheapest sensor. It has a 2 degree, but no, it's not 2 degree. Is it 2 degree? Plus or minus accuracy, I think. It's not that bad. If it's around the temperature it's supposed to be, I don't mind. And again, plus or minus 2 degrees is not that bad. I don't think it's plus or minus 2 degrees. I think it's like 1. So, now that I'm thinking about it, I think it's more around the lines of 1 degree, plus or minus. I can look it up later. That's fine. We're going to save it. And now that we've got our code done, so this was all generated by just adding a new device. The Wi-Fi, again, was just generated because it's my Wi-Fi. Light, we need to have our output, our light, and we need to have our sensor. Now that we got that all done, we can install it. Plugging it into the USB port of my Home Assistant, my Raspberry Pi that I'm using, and just hit it go. And then it compiles it all, throws it onto and it takes a minute or two to do this all. But after it's done, it's done. So, we're going to go back to the workbench right now. We're going to zoom out. We're just going to have the main... Where's main screen? We're going to have that in the corner, so that way we can see when it's done. But right now, we've got our little thing right here. Oh, all the glue has dried. I want to kind of pick off whatever's there. I don't want too much glue on this darn thing. And I think we're going to leave this for right now. We're going to work on the plug device. So, right now, we got our 3D printed model out. And what this does is, I'm just going to show you a demonstration. Is it's just going to have the plug of the cord of the lamp just plug right in there. And we're going to have these contactor bars in these slots right here. We're going to just shove them in there. And that's going to connect that, have a connection there. And we're going to throw this out to a USB, which is going to sit nicely right there. And so this can just plug right into a normal computer or whatever. And so that's how I'm going to do this. But for right now, alright, we're gonna, no, we need to do this first before I start assembling everything. Alright, so let me take the shade off. We're actually going to install this, our new bulb. Oh, our main thing's done. Main screen. So, as you guys can see right here, so the DHT sensor is not, it's not connected. So it's saying, hey, we got this. Also, we have notifications right here. Check it out. New devices discovered. Here we go. Grandpa's lamp. Configure. Do you want to add it? Yes. This is going to be in my bedroom. And it should be right there. We got the lamp, we got the humidity sensor, and we got the temperature sensor right there. Right now, I know... Okay, so we can do this. There we go. So right now, if I wanted to, I can turn this on and change color. Oh, wait, nope. Nope. I gotta put that in and add to Lovelace, but we'll do that later. We'll do all this later. We'll do all the setup after I have the device built. So let's go back to Workbench. So now here comes the most important part, is testing this darn thing. Now it's a bit off, and I don't want to tighten it too much. There we go. So now it's screwed in, our makeshift lamp. I gotta test the polarity of this. Before we actually hook up anything, because I don't want to accidentally fry the circuit by inverting it, which would be something I would do. Because I haven't had the best luck the past couple days, if you guys have been watching. A lot of my projects kind of failed. I don't know why. Alright, so let's get rid of this main screen for now. So we're going to test the connectivity. And we got our positive lead up here. Now which one of these darn things is... Nope. Are we not connected? What's going on? Okay, so that's one. That's the other. Okay, so it looks like... Okay, so it looks like, if y'all are watching, I'm just... Ooh, it's like really bad because it's trying to focus on the lamp. But yeah, no, it looks like... Alright. It looks like the faraway plug is the negative. The one that's right next to... That's going straight down from this is the negative side. And then the one that's away from this cord, because like this cord is like on an angle, it's like more towards that side. The one that's away from that cord looks like it's the positive. Oh, yep. Alright. So now that I know that, positive, negative. We are gonna go... we gotta make the bottom structure? I don't know, like, this is really confusing me right now. So we're gonna get rid of that for a second. I guess I could swap it any way I want, because then if... Alright, so we're gonna start with... I don't know how I'm gonna do this effectively. Because I'm going to need to use wire. Just going to grab a tiny bit of that. And we're just going to strip it, I guess. I could always just take away wire. I can't add it, so that's... Oh no. Oh no, that's stuck in there now. So I made these things super tight because I know it needs to make connection with the... So the question is, do I want to just connect... I'm going to have two of these connecting on both sides. So, do I want to pass it through? I think that might be the best way to do it. But I'm just going to have it connect to one for right now, and then I'll come around the other side and I guess ink. I don't know. I gotta figure this out as we go. Okay, so I'm gonna put more wire on it. I have just a little bit of room. No, I got room. I got room for this. So I just got it right there. And then I'm just going to solder this to that. Just realize this contains a lot of metal. And I don't want to be that guy, but like... And do the back side a little. I don't want to get it entirely done. Just want to have that hole covered. Alright, there we go. That's good enough. I'll wait for that one to cool down. We're gonna do the other one. Grab, yeah, about that much. And again, I'm probably gonna cut these down just so it fits in. Alright, there we go. That one there. I don't need wire anymore. Put those away. Remember, it's always a good time to put stuff away when you're done with it. The only things you shouldn't put away completely are the multimeter or any safety equipment you could use in the future. Everything else, just go for it. Actually, I need a little bit more of this. Flip it on its back because this is a little bit more flatter over here. The other thing you should always have is a nice workbench. Cleared off. Free of any distractions. I wish I had like a tack welder or something just so I can get this done stupidly fast. Because the metal is actually causing this to not stick well. Right there. Let's see if this one... Well, I guess this one's alright for now. Nope. It's not at all attached. Well, I guess it's fine for now. I really hate this. I really hate doing this. Because when you're doing electrical stuff, it needs to be a solid connection. I can excuse it because it's going to be 5 volts. It's not going to be mains voltage. So... And there we go. We got our 2. Which side's negative on a USB again? I forget. USB. Google, why don't you remember me doing this? I do this at least once a year. Or at least once a month when I'm doing projects. Cool. So if it's... Okay, so if it's this way, the first one here should be positive. On this side, positive. And then the one all the way... That... Okay, so... That's negative. This side's negative. Okay, so we're gonna do it this way. Alright, so we're gonna... Oh! Alright, so we're gonna try and... We're gonna try and squeeze these in over here as best we can. Oh, come on. This is the hard part, because like I made these channels so thin for the reason that it's not gonna... The reason it needs to have a tight fit and connectivity, and I totally spaced on... Well, I didn't space on it. I knew it was going to be a tight squeeze. But if like any of the metal doesn't line up right, then it's just like this. Nope, I need to redo these. Because this thing, I don't need to redo it. It's pressed into the right shape. It just needs to not wiggle as much, I guess. I don't know. It's so bad. I want to forgive myself for this design, but I've already... Nope, it's already locked in. I can't undo it. I gotta figure out how it can just... Relax. And try and spread it out. I want to try and spread it out so that way it has better connection. And even if it attaches to the wire more. Ow! Fuck. There's that one. Okay, so we're gonna try the red as well. We're gonna try and do... I know the reflections are screwing with the camera. I'm sorry, guys. Alright, so... Again, this side... Wait. This side's gonna be... this one. Alright. Alright. I gotta figure out a better way of just putting these in. There's one. And I guess just ram it in there. Ah. too far forward. This bead is getting caught up in the inside. I never planned for it to be this big. So that's going to be there. There we go. I kind of need to move it up a bit. Okay, so I'm trying to move this into position, move it up. I don't know. And then just have this there, and we're just gonna throw some solder on real quick. Level it out so it's flush on the top. Alright, and we're just gonna quickly solder that in there just to strengthen up the stranded pair of wires, as well as try and make a connection with the make the connection a bit better. We gotta do this fast because I don't want the plastic to melt, because it's 3D printed plastic, and that's not really great. Okay. There we go. I don't know what that is. We're getting that out. We don't want any kind of metal shavings or anything in here, because again, electrical connectivity. And I'm just gonna try and there we go. Alright, so it might not be the best thing for it, but it's gonna be there. Alright, the next thing is this sucker. Alright. So we're gonna try and just try and get them both into channels and then slide them in. And then I can go kind of down with them. Same problem as last time. It's just, or same problem as the red wire. This, you see, it's not like, it's overlapping the area that I had set up for it, so it doesn't want to sit nicely there. I think we're going to rely more on compression than anything else, to be honest on this. For at least this part, compression more on just having this wire, just have a bunch of solder on it and just push it against the walls and everything. So I know if it fails, it's probably going to be here. Okay. I don't want to hit it. I want to just have it there. There we go. Alright, so that's good. We're going to pull this down. We're then going to attack it with a bunch of solder. I know you might not be able to see this, but I need to do this so that way it doesn't... I'm just tacking it down to the hole on the bottom just to try and get that. There, I guess. Yeah, alright. So I just made that giant blob right there. We're gonna try and do some more right here. Oh, this whole thing is, ow, hot. Yeah, okay. And as I suspected, we've got too much wire. So... it's this way. And I don't need the data wires. So we're going to try and pull those back and just... I'm going to clip them. Because we don't need the data pins there, the 2 data pins. Or I could do that and just do the whole thing. That's cool. Yep, nope. Yep, so I just took slid the 2 pins out that weren't needed, the 2 data pins in the middle. All we need are the positive and the negative for this. Alright, so the next thing is we're going to get some hot glue. I am so sorry. We're going to squish this in here. We're going to pull it out some because I know that's not the appropriate size for this. We're going to do a USB check to make sure it fits properly before we continue on with whatever I am supposed to be doing. Yeah, it fits in a USB. Yep, okay, so next. I guess I could just strip the whole thing, can't I? I really don't want to. Alright, so first I'm going to cut these to make them more manageable. There. Next, I'm going to take these. Oh, son of a bitch. Trim a bit more off. No! It just came out. Alright, so let's just try. At least the ground I can grab. Nope, still needs to be shorter. All these strands are too big. I can't even see right now where the heck the pin for the ground is. Everything's just so intricate. I think I'm on it. I'm definitely on it, I believe. Because this is just, you gotta line it up to the pin. Like that one's right here, if you can see that. There's a pin here, there's a pin there for ground. And I just gotta get it right there. Yeah, no, I was on it. Just gonna use the blade to push it into place. Because, like, these strands are kind of like... It's stranded pair, so it's a pain in the butt to do. But you get more flexibility before they break. Most of the time. So we're just trying to get through that. There we go. And just oversaturate the shit out of it so I know I made a connection. Which is not the best way of doing solder work. Shit, now I gotta replace this. I'm pretty sure I can't just... I gotta take them out. What pains me the most is this actually made a solder connection. Like, it literally bonded with the fucking metal. Which I'm like, how? Yeah, no, this literally bonded with the metal. I don't want to bang it up too much because then I have to do it all over again. Anywho, let's try this one more time. The problem with the fact that it bonded with this means it's going to take more time for it to free flow. There. Oh shit. Nope. Here. Since my plier or my strippers are being used. Oh. I don't want too much on there because, again, too much and I'll have to cut it. There we go. There, wow. I might not have the ability to do it, but we'll try it. So I gotta make this a little bit bigger next time. I need to make these strips a little bit longer, I think. Okay, so I gotta... Alright, hold it with the pliers, because I can't bend that bubble right there of solder. It's just messing with me. Alright. Maybe that'll do? No. Well, maybe. I have to see what's gonna happen. Okay, slide. Get these two on either side of that. And slide it right in. Oh, nope, other way. Shit. Let's directionally inclusive, I guess, if you want to call it that. Oh, what the shit's going on here? Get that off. It's come straight down, I think. It's just that. There we go. I got one of them in. You know what? I'm okay with that. I'm going to try and build it up over the sides so it doesn't... that's fine. I can see a solder ball in there. There we go. Take that out. Clear out anything that's not supposed to be there. Nope, needs to go smaller, and I accidentally chopped off half of it, so it's good. Well, I guess the whole thing's coming off, ain't it? As long as it doesn't touch the... As long as it only touches the positive lead, I am fine. Okay. I think every strand needs to be accounted for. Because one bridge to anything will destroy this entire circuit and cause a short. Alright, so we got that done. Alright. So right now, I'm just gonna I'm gonna solder the whole thing. I'm gonna put a nice extra heaping helping over here next to the positive side. Alright, and that should, in fact, do it. Let's see if we can focus in. How is it not focusing on any? Oh, it's because it's metal. It doesn't like the shiny. So we're going to plug this into a USB. Yep, we plugged it into our USB port. Now we're just going to test it. See if it does do what it says it does. There we go. Oh. going to change the voltage. And I'm touching the contacts. Oh. We're at 5 volts. Houston, we don't have a problem. So now that we got 5 volts, that's positive, and that's negative. Yep, okay. So we got that done. We're almost finished with the project. Holy cow. So, we got this done. No, I still need to do the right thing. Besides, let it cool down. We're going to cement it in glue. Because hot glue is going to cover everything. It's going to be our insulator. There we go. There. And then we're going to do... Okay, we're going to do... Oh. Thank you for following True Eyes. Now we're going to do... Oh, God, the test. Okay. So this should... I see what's going on here. You got this one a bit out of the way. They're closing in too. They're too much of a... Oh, I can't get a good view because it's all shiny and the camera doesn't like that. Alright. So wait, what did I say? No, I think I'm good. The negative side was supposed to be closer to the... because the cord's lopsided. So I think this should be the correct orientation of the plug. Oh, come on, you. Next time, I gotta... There we go. There's that. And now we have a top for it. Nope, other way. That I 3D printed. So now this is just gonna all fit here. We're gonna do my best part, which is what I like to do is using my M4 screws. Do I have a screwdriver? Oh, I don't have a screwdriver on me. Let's see if my iFixit kit has it. Hey, if you don't mind, can you explain what is AC? Still a student, though. Okay, so AC, is alternating current. That's when, in DC, direct current, it just goes in one direction. Alternating current, swaps basically the positive and negative of the circuit every couple seconds. They use AC because it's easier to transfer over wires. You won't lose a lot of energy. In DC, you lose a lot of energy in your wiring. So that's why you don't have everything running off of basically batteries. AC current is created by generators, which kind of like motors. If you ever use it, it uses generators, which are which is hard to explain. It uses magnetism to create electricity. And with that, the generator keeps spinning. If you ever, have you guys ever had like a motor or something, and you kind of it says not to rotate the motor, otherwise your thing will break. And if you've ever like done it, you can see like LEDs light up or something, or the thing like activate with powers for like a few seconds as you change it. That's basically what a generator does. But it goes super fast, and AC currents change the direction of current. And so again, AC has its uses. Again, motors and a few other things run better off of it. It travels over wires more easily than DC. But everything in your home, basically, that's LEDs, anything. It transforms it back. It transforms it from an AC power usually to a DC one. And if you're in America, it does it usually about 50 times a second. It swaps the negative and positive 50 times a second, or 60 times a second, sorry. 50 times a second if you're overseas in basically anywhere. Now, are you an American student, or are you just world studies, I guess I'd call it? There we go. And I should have actually tested this before I closed it up. Shit. I keep forgetting to do that. So, yeah, you're outside the US. Okay. Depends on where you are. If you're in China, there's no real... If you're in kind of like an Asian culture, there's like... From what I've seen, there's little to no regulation on some places. US, you have to be standardized, otherwise they like mess with you. The energy department messes with you, which I really hate, because it limits some states. You can't get solar panels because of that, which is kind of dumb. Where did I put that? There we go. Alright, now let's test the voltage up here. Now if I can get the correct voltage. 5 volts. So I'm testing it from up top here. Oh, my lights are bouncing around the... But you see, I'm up here with the thing, and it works. So I've got a steady connection. Well, I don't have a steady connection because I'm putting my voltmeter here. And we have 5 volts here. So this connection piece works. Oh, wait. Was it the right polarity, though? I want to make sure that's correct before I plug in my ESP32 to it. Yeah, okay, it's the right voltage. It's not negative. Good. But like, so I think it's 220 in Europe, 230 in Asia for voltage for AC, and, yeah. By the way, does AC create electromagnetic impulses? And if so, does it interfere with any transmission? Yes, it creates an electromagnetic field, definitely. Because of that swapping back and forth, like super fast, it will create an electromagnetic field, which is actually and it won't affect you, unless it's like stupidly powerful, like, which is why they keep, you know, those huge transmission lines up in the sky that are like stupidly high, and it's like the high current tower voltage, you know, like that's the stuff you want to stay away from, but only at like a certain distance. And even still, electromagnetic waves or fields that are created aren't that powerful. If you ever seen, I haven't seen it, but I want to reference it. What's that drug show called? Breaking Bad. So, like, if you ever saw that one where he goes and he erases all the hard drive data from, like, the vault or something of a sheriff's office from outside, that's almost impossible. That's impossible. There's not enough power for that to happen. Even with the right equipment, you can't really affect. You can't affect too much of the world with electromagnetism, because it steadily decreases over time, or over distance. It's like you need to have so much power, which is why Magneto is kind of one of the best X-Men, because he kind of has unlimited power over magnets, which means he kind of has unlimited power in general. Which is why I think he's one of the most broken ones out there. So I'm just screwing this in right now. Okay, so a helpful way of the AC electromagnetic impulses is something we can use to our advantage, because we can calculate how strong a magnetic field is, and because the power lines are basically based on a standard either 120, 220, or 230 volts, you can use that magnetic field to calculate the amperage of a circuit of wiring, just by having like a clamp. There are clamp devices that go around the wire that'll like literally circle around it, and you can clamp it, and you can tell how much power is going through that based on the magnetic waves or electromagnetic waves that come off of it. And that's great. So that way, like amateurs like me, I can just determine the voltage of anything, or the power rating of anything. if I have one of those devices. And it's like super great. Mhm. Oh, did I grab the wrong screw again? Darn it. But I generally stay away from AC just because it's usually, you can't find it at a low voltage range. It's usually stupidly high. And it has to deal with mains voltage, so when you do stuff with mains voltage, you gotta be stupidly careful. And I don't like to do that a lot. I like to be reckless. I like to just jump right in and do things. So AC is not the power. Well, okay, let me check that. AC voltage at high ratings is not for me. I don't like to deal with mains voltage. I'm always skittish around it, just because, hey, it can kill you. Circuit breakers don't prevent everything, and if it fails, you're kind of screwed. Wait, is this? Yeah. The reason, what's now? What was AC? Thomas Edison. Yeah. No. Thomas Edison was DC. Nikola Tesla was AC. And again, AC is more easily transferable. It's not... DC can kill you the same as AC, but generally AC is usually has a higher voltage range, which contributes to killing everyone. So how will I die if I am touching household wires? Okay, so here's the thing. So if you shove your finger into a socket and you're completely grounded, just one of them, in theory, you will not be hurt at all because you need to complete a circuit. If you're not grounded, however, you will probably, if you're touching it, it'll go from one hand down to the other hand, which has the other wire, and it'll go across your chest, which will screw with your heart. I'm gonna put a little hot glue right here, finish off sealing this. But yeah, no, the electric current will pass through your heart, and it will mess with the electrical impulses with your heart, stop it from working correctly, and you will die that way. Either that, or if your circuit breaker doesn't hit then, after a few seconds, it'll start frying you. You'll be basically cooked from the inside out, which is not a good thing. Ugh. Alright, so that should... Okay, so this is done. Now we need to work on the top part. So, before you joined, we flashed our ESP8266, which we have right here. Oh, I gotta like zoom this out now. And we just plug it into our board, which is already hooked up with everything. Oh, nope, other way. Okay. Alright, so now that that's done, we're going to try and jam this in here. We're going to plug this in and pray that I don't fry it. Are you on? Actually, we're going to kick this out for a minute. Can I be saved later? Depends on how long you're under the influence of the shock. Again, if you just touch it for a few seconds and the circuit breaker, which is supposed to trip to prevent anything from happening to you, because a lot of amperage will go through you directly to ground, directly into the ground. It'll blow the fuse, and hopefully you'll be you can survive that. Depends on how quickly it goes. You can just come up with a nasty shock, all the way down to you need CPR and you can be resuscitated. So this is there. I want to see if this thing comes up. Alright, are we still good on the voltage? Where's my voltmeter? I know we didn't change too much, but I'd like to double check and triple check my work. Yeah, and again, CPR, resuscitation, whatever. But if you're too far gone and it starts cooking your insides, depends on what it cooks. And I'm not a medical professional, so I don't know what else. I don't know what to do or how your body will react after that point. I just know that I don't intend to do that to myself. 9.3, we should be running. We good? Alright. Oh, configuration. So I'm just doing some stuff on main capture. Here we go. Device services. One device. I can't grab it. I hate this so much. Home Assistant really kind of has this thing where it doesn't like to reconnect too fast. Alright, and we are gonna just upload the code again. Install from this there. And so we're basically reprogramming the ESP8266 right now using ESP Home, which is part of Home Assistant. Alright, serial port. Come on. How are you failing? Okay, what's going on here? Let's retry this. Okay. There. It should be working. I don't know why it doesn't just work right off the bat. Alright. Alright, it's connected successfully. That's online. Alright, so I'm going to try and pull this. Okay, so I plugged it USB-wise into my Raspberry Pi off to the side right there. And we still got online. Good. Okay. Offline. What's going on? Are we getting 5 volts from... Because I know we're getting 5 volts to here. Right, we're still getting 5 volts. .8. Yeah, so I should be getting 5 volts here. Ouch. That could have just tried it. Damn it. I'm not getting 5 volts here. What the hell? Yeah, I'm getting 5 volts to the chip. This is not good. This is not good at all. I've been having problems with ESP or this Home Assistant for a while now, and sometimes I kind of want to swap over to Tasmota, which is another form of wireless programmer for ESP32s and 8266s, just because it uses the MQTT protocol instead of whatever ESP Home is using. It's kind of like their own way of getting their own protocol, which sucks. Because I really like to have everything all in one, but I'm probably not going to be able to do it. Integration devices. Yep. Okay. Can I turn you on? Nope. What's going on here? Is there like something I need to do to get this running before? I'm just gonna plug it in here. Did I wire something up wrong? What's going on here? ESP Home. Yeah, it's online now. So we messed up something here on the board. I don't like this. I don't like this at all. It doesn't give you a reason why. Because now I can go to configuration. Okay, so bring it back into main screen. So, like, when I plug it into the thing, it says online now. And this is what's been pissing me off for the past couple days now is the way ESP Home has been doing this is really one device that. And see, now I can virtually turning on. It's sending a signal to the thing. But, like, what's going on here between me plugging it in? Yeah, that's fine right there. But now when we go to... Okay, so we just plug it in here. And it's getting 5 volts. Because I tested it. It's still doing its thing, right? Yeah. Okay. Yeah, no, it's still on. Virtually, it's still on. Actually, can I do that? I'm gonna plug it in. And it's spazzing because there's not enough power for this. Settings. Add to Lovelace. Next. Add to Lovelace. Alright. Overview. There we go. Oh. See, they turn on. But as soon as I take this off, will it still work? Oh yeah. Okay, maybe it's just me. Maybe I just get too rowdy because it doesn't connect right away sometimes. So in theory, this works. In actual applications, it may not. So, like... And you can see all the lights changing colors as I change the color wheel up here in the screen. So... Okay, so in theory, this all should work. In theory. In theory. Oh god, theory. I fucking hate theory. Because it never happens right. So now I gotta unplug it. And we're gonna just set everything in. We're not gonna touch anything else. It's just coming straight from this wall outlet. The only cord that's plugged in is the USB port. And so now all I'm gonna do is do the finishing touches to this project. And hopefully I don't have to take it apart. So first, power. We're gonna not be dumb and accidentally cross wires because I don't want to do that. We're gonna shove everything. We're gonna turn on lights. We're gonna get more. We're gonna get more. We're gonna treat this better with respect. Because again, I don't want to redo this. Swear I don't want to redo this. So, if you look, we're just jamming this in here. Oh, wait, which way am I jamming it, though? Which way I can get easier access to. So I want to jam this kind of, in a way, down in, where it's not messing with any of the wires, and it's also... Wait, why am I doing that? I made it a light bulb. So I don't have to deal with the large, unwieldy thing. That was kind of my whole thought idea right there. So I kind of want to hot glue this so that the sensor, if it focuses, I want to grab it so that the sensor for temperature and humidity is kind of poking out there. And then the other side's going to have the wire coming out. Oh, wait, which way is... Oh, nope. I actually designed it for the other way. Sorry, my bad. And we're just going to Get a little bit of hot glue. And we're just going to jam it in there. Alright. Hopefully. This doesn't mess with anything. And we're just doing this. We're just gonna try and... Oh. I'm just gonna do some hot glue right there. No, 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 no. Okay. So I don't want to cover the bottom with any hot glue or the top. I want to have this thing free flowing, so that way it doesn't. So that way it can actually read the temperature and humidity correctly by airflow and stuff, because it needs to have airflow in order to do that properly. I'm trying not to cover it up. And I'm also pressing the board inside there. I'm just trying to get it to focus. There we go. Focus is second to me because this project I've wasted too much time on it, and that was hot glue. That was hot glue. The only reason I use hot glue is because usually it sticks pretty well after it cools down. You don't have to worry about it too much. Once it's in place, it's in place. Okay, so next we're going to take our LED strip that we have here, and we're going to jam the wires. I kind of want to secure these wires somewhere else. We're going to snip them. Oh, wait, can you guys see that? Okay, because these are power wires. I don't want to have them dangling, so I just cut them off. That's fine for right there. That shouldn't give... Unless I'm stupidly unlucky. Like, stupidly unlucky. It shouldn't cause any problem. Now, I'm going to connect the wires. And just stick it right in there. Alright, so now the next thing is we're going to put this on the outside of the bulb. The 3D printed bulb. So we're just going to take the sticky stuff off the back. And we're just going to casually roll it around the outside. Come on, you. And then we're just going to keep rolling it. And hopefully I have enough space on this bulb to have it all. I can stick those down in there. I feel like this is gonna come off. I hate this cheap glue that they give with this thing. So we're just gonna put some hot glue down every so often. I'm gonna redo this entire thing. Every, like, little bit. Ow. Ow. Alright, so I hate this so much. Because I'm a righty and I threw everything on the right side, which is not supposed to be there because it's left. I fucking hate rolled up shit. Because it tangles so very fast. Let's zoom out for this, because this is going to be more of a zoomed out kind of thing looking at. Alright, out of hot glue. Why not straight hot glue from top to bottom? So, yeah, no, that's kind of what I'm doing. I'm doing it in a circular pattern, for these strips. Because I feel like I'm gonna do a lot more better luck with it on every single piece, on every single, like, surface as I follow it. Primarily because this is PLA plastic, 3D printed, and so this, it doesn't have a lot of grip, so that's why I'm using so much hot glue right now. PLA does not like to stick to anything but itself, and even then it's a pain in the butt to do it. So I want to cover everything in it to get that maximum God damn it. That maximum coverage. But of course it always leaves spider webs behind. And these are like these LEDs are like 5 years old or something, and they are something I bought off of eBay. Let me just get rid of this really quick, because that's part of the reason I'm getting tangled up, is the waste. So I don't trust any of the adhesive. So because of adhesive, I don't care for it. So bad adhesive and PLA not sticking too well to anything other than PLA. That's the reason why I'm using so much glue right now. Oy. One more glue stick. Also, this hot glue gun, I believe, runs directly off of AC. Well, not directly. It might have a step down for it, but usually heating elements are AC. So, back to our previous conversation about AC. Like this stuff. I know it's not done. I'm still kind of annoyed by the amount of spider webs it can create. Let me just finish it up first before I start freaking out over it. There, and we can just throw. And because of the added glue and the tightness that I'm pulling it, we came all the way to the top. Okay, now I just gotta let some of it sit, start picking the stuff off the bottom to make it look cleaner. But we got our DC light bulb right there. Now again, you don't want to plug this in directly to AC. It wasn't designed to take mains voltage. First off, being 5 volts, it runs off of 5 volts, and mains AC is here in the US is 120. So that's not the greatest thing to suddenly jolt this thing with. I doubt it could even do 12 volts. These LED strips are only rated for 5 volts. It can go up to like 7 or something, but then it just blows itself out. Yeah, it'll just rip right through this. So don't, if you were to design something like this using the WS21813, 12, yep, WS21812B LED strip, only use 5 volts. Alright, so that's all good. Alright, so now we got our bulb. Test it. Yeah, I'm just trying to get all the... I got most of the... clean up later. Let you guys see the end result of everything. A little cleanup though. Alright. Move the hot glue gun out of the way. And nope. We're turning it off because it's stuck here. It got in between my damn cutters. How the hell did it do that? Okay, there we go. Clean up a bit so that way that doesn't happen. That's another reason why you always clean up. And if you heard that, that's the other reason you clean up, because you knock into things. Alright, so we got everything. Alright, so we got our light bulb. We got our... I'm going to cut these ends off too, because these are also power lines. I still want them, so I'm going to tuck them in here. Because if something were to happen and I need to apply more voltage, it can distribute it a little bit more evenly. Alright, so there we go. And of course that shifted. Well, it's not too far off. The Dht sensor is kind of stuck behind here now, because I was rotating the bulb while the glue was drying. Alright, so we got... Alright, so we plugged it in. And now I gotta wait for the Wi-Fi to connect to it. I really hope it does this time. I usually give it a minute or two to figure it out. Or we can go into, put the main screen up. We're just gonna restart Home Assistant and see if it detects it on its own. Because now I can't pull out the Wi-Fi module and just manually reset it. So I can have this over here. We can blow this up a bit bigger. Sun off is started. Alright, overview. Don't tell me. Don't tell me I have to take it out every time. Come on. $37 seconds ago. Yeah, it's unavailable now. Show more. I wish you could just reset it when it has power. Oh, wait, I do have a... Oh, the reset button's all the way down in there. Oh. The reset button on the dang thing's all the way on the other side. I really have to wait until this loads then. And I don't know. I don't know when that's going to happen. Oh, shit. Now I'm just going to pull out the hot glued thing. Yeah, I'm just going to pull out the hot glued board. And as soon as I do that, it's gonna freaking connect. I know that for certain. Well, unless... Nope. Doesn't want to. Damn, I put a lot of hot glue down there. I might just leave it free-floating next time. I don't want to put in any more hot glue. Come on, peel off. We're gonna pop you out. We're gonna reset you. Oh, can I not even take that off? I can't even get that off, can I? Even if I wanted to. Come on, hot glue. Yep, hot glue is not the end all. This is why I choose hot glue instead. So, I mean, in theory, it should just... In theory, it should work. So let's reprogram it. ESP. Home. You should be. The quality of these boards has gone down over time, I've noticed. Because now, as soon as I plug it in the second time, I have to plug it in twice. It then pops up. So, I don't know if you can see. Now it's online. Online. Overview. Yeah, I can do that. Alright, so snap it back in. This is the biggest pain of all. Because I know it should auto-connect. For some reason, it doesn't like to do that. Oh, wait, nope. No. Wait, okay, that's fine. It's still connected, right? Oh. Okay. Actually, I don't know how I'm going to do that with the thing spinning. I'm going to disconnect it really quick. Spin this together. Oh. And... okay. Disconnect it. In theory, this is all good. Whatever. Close that on. Overview. Hey, there we go. And our lamp is complete. And now for the finishing touch. There. There we go. And now y'all can see. Wait, I can't zoom it out anymore, guys. So we got that. It's actually pretty good. Let me turn off. Alexa, turn off lamp.
Okay.
So now we're in almost pure darkness. And we got this thing going. So it works. Hey. And hopefully I can figure out what goes wrong with it on another time, because I think it's almost 2 in the morning. We spent over 3 hours on this, 2 hours and 45 minutes about on this project. So I think we've got a pretty good thing. And it's even got its own switch. I'm not going to touch it, but it's got its original switch here. So if I ever wanted to just turn this thing off by hand, if it's freaking out, besides pulling the plug, I can do that. So, any of you guys have any more questions before I end the stream? Or are you guys all good? All right, well, thank you guys for tuning in. Yep. Thank you guys for tuning in for this project. Thanks for staying a while. We finally got everything set up, so now it runs off of USB. This old lamp with its original cord, AC cord, and everything is now running off of USB. So thank you guys. Have a wonderful night, evening, afternoon, wherever you are in the world. And I'll see you guys next time. Bye.